Machine learning has transformed the way we solve problems, whether predicting stock prices, recognizing faces, or creating smarter robots. Today, we're diving into the three main types of machine learning: supervised, unsupervised, and reinforcement learning. By the end of this video, you'll understand not only what makes each type unique, but also when to choose each one. Let's start with supervised learning, where the model learns from labeled data. Imagine a classroom where the teacher gives you a picture of a cat, along with the label cat. Over time, you start recognizing cats easily because you've been taught with labeled examples. In supervised learning, the machine is trained on known input-output pairs. Once trained, it can predict outcomes for new, unseen data. For example, this approach is used in applications like image recognition, predicting stock prices, and diagnosing diseases. Common algorithms include linear regression, decision trees, and support vector machines. Supervised learning is ideal when you know exactly what you're looking for, such as classifying emails as spam or non-spam. Next, we have unsupervised learning. Here, there's no teacher to provide labels. The algorithm has to find patterns or groups on its own. It's like exploring a new city with no map, just wandering around until you start to notice patterns, like which areas are busier or quieter. This approach is great for applications like customer segmentation, where you want to group people based on buying behaviors or interests. The algorithm examines unlabeled data and detects structures and patterns, like who buys what or how often. Popular unsupervised algorithms include k-means clustering, hierarchical clustering, and principal component analysis. Unsupervised learning is powerful for understanding data trends when you don't have labeled data. Finally, we have reinforcement learning. Imagine you're teaching a dog to fetch a ball. Each time it does it correctly, you reward it with a treat. Over time, the dog learns to fetch the ball to get a reward. Reinforcement learning works similarly. It uses a trial and error approach where an agent interacts with an environment, making decisions, receiving rewards or penalties, and ultimately learning the best actions to take. This type of learning is used for complex tasks like training robots or creating AI for video games. Common algorithms in reinforcement learning include Q-learning, Monte Carlo, and deep Q networks. These techniques allow machines to adapt and improve their strategies over time, just like a game character learning how to navigate a challenging level. So, how do you decide which type of learning to use? Here's a quick recap. Use supervised learning when you have labeled data and need clear outcomes, like predicting weather or diagnosing a condition. Go for unsupervised learning when you want to explore and find patterns in unlabeled data, such as clustering customers by shopping habits. And choose reinforcement learning for tasks where trial and error is essential, like training autonomous vehicles or robots. To recap, supervised learning helps in applications like forecasting sales and detecting fraudulent transactions. Unsupervised learning is perfect for clustering and customer segmentation. And reinforcement learning is revolutionizing gaming and robotics, allowing machines to take on increasingly complex tasks. Thanks for joining us. For more AI insights, keep learning and stay tuned.